Okay, remember we're working on net ionic equations, and we want to get these down perfect because we know that question number 4 on the AP test uses just this format of question. So the worksheet we're working on right now comes from Adrian Dingle, a venerable AP chemistry teacher, and we want to work our way through this particular worksheet. So we're going to start here on what is titled question 1, and I'm going to be doing some writing up in this part, but that's just kind of little notes to myself or things that I'm thinking about. Down here in this box is where we want our neat, completed, final net ionic equation. Everything balanced, everything in net ionic equation form. So here we go. This first equation starts with sulfuric acid. And I tell myself, I know what sulfuric acid is, H2SO4. It's a strong acid, so it's going to dissociate into ions. And I know that, but right now I'm just kind of writing this so I remember what's here. Okay, I also have lithium hydroxide, and it also is in solution. It tells us so right there, in solution. So I know that when I react an acid and a base, one of the things I'm going to get is water. And of course, water doesn't dissociate to a large degree. So we're going to write it as H2O. And of course, I also know that in my solution, I'm going to have lithium and sulfate. And lithium sulfate will be very soluble, so it will be in aqueous solution. It will be dissociated. So I can tell that this ion is going to cancel and this on both sides, and so will the sulfate cancel on both sides. Now I have the things I need to write my net ionic equation, but I've got to be really careful because I'm not going to write H2 down here. No, because I know that those are dissociating individually as separate hydrogen ions. And I'm not going to just write OH, I'm going to write OH and its charge, because that's what we've got up there. I just didn't write the charge in earlier because I was just writing the overall equation. And we're producing water. The spectator ions are canceled out. We've got to remember they're there because somebody might ask us, what's the color of this flame that's produced by the products? And you would say, it's got lithium in it, it's probably going to be red. But they ask you what a property allows the hydroxide ion to be classified as a base. And so we go to our definitions of acids and bases, and we know that bases accept protons. And so that's what I'm going to put here. Bases accept protons when they're in solution. And remember, this hydrogen ion is really nothing other than, where's the pen I want? This is really a proton. So the base accepts that proton. And so that would be all 5 of the points for A. You would get all 5 of the points based on those answers. Let's move to B. A solution of lead nitrate is added to a solution of potassium iodide. So I'm just going to kind of sketch in here. Here's lead, here's nitrate. I know, NO3. I know their charges. I know what the formula would be. It's in aqueous solution, so it will dissociate completely. And potassium chloride is in solution, will dissociate completely. And they're going to react. Well, this also is a double replacement reaction. Neutralization reactions like the one up here can be thought of as double displacement reactions. This is a double displacement reaction, and it's driven forward by the fact that we're producing an insoluble precipitate. The insoluble precipitate that's going to be produced will be lead chloride, lead 2 chloride. And can't hardly see what I've got here. It's kind of sloppy looking. That's a problem. You might want to do these on some other piece of paper rather than scratching them out here. So we still have potassium nitrate. And potassium nitrate we know is going to be an aqueous solution because it's very soluble. It has an alkali metal to begin with. So I'm going to get rid of my spectator ions. I know the potassium ions are going to be in solution on both sides. I know the nitrate's going to be in solution on both sides. So when I write the net ionic equation, can I just write Pb here? No, it has to be the Pb ion. That's what we had up there, is lead ion and chloride ion, and I'm going to make lead chloride. So we get the here. So I have to balance this equation by putting a 2 right there. Double displacement reaction. There's the net ionic equation. Other than lead plus 2 and lead, pure lead metal oxidation. So what other oxidation state is common for lead? And that would be plus 4. Cycles through. So blue color here, and do some just scratching up here. Sulfur dioxide and water. Those are my reactants. And I'm going to, well, how do I know what I'm going to produce? Well, we had a rule that says if I have metal oxide and I add it to water, I'm going to oxy acid. And the cation in this oxy acid is just going to be the sum of these oxygens here. So that's going to be SO3. That's sulfite. And so it has a charge of -2. And so this is sulfurous acid. It's a weak acid, so it doesn't dissociate to any large degree. So the net ionic equation is going to be SO2 plus H2O, and because this is a weak acid, it's going to stay together in aqueous solution, and so that is, it's balanced. That is the net ionic equation. Now it's still an acid, so if you put it in, if you put the pH indicator into it, it's going to show up as an acid, and so a red piece of litmus, excuse me, a blue piece of litmus will turn red. So when it says to what tell what you would see, you would just say the paper is going to turn red. Something like that. That would be all 5 points for C. And so that's how you do question number 1 on this worksheet. So look that over. See if you have any questions. Email me. Come talk to me about it. Leave a comment at the bottom of the page. Do whatever you need to do. Do it.